Have you ever pondered over the intricate relationship between logic and mathematics? Do they represent separate entities, or are they two sides of the same coin? Let's dive into this enigma, an intriguing mystery that has engaged the minds of philosophers and mathematicians alike. At the heart of this exploration is a man named Bertrand Russell, a titan of philosophy and mathematics, whose insights continue to shape our understanding of these two fundamental concepts. Russell, in his seminal work, Introduction to Mathematical Philosophy, penned while serving time in Brixton Prison for his anti-war activities, set forth a revolutionary perspective on the relationship between logic and mathematics. In his words, logic is the youth of mathematics and mathematics is the manhood of logic. A provocative statement indeed, but what does it really mean? In his book, Russell approached mathematics from two distinct directions. One, driven by a mechanical kind of simplicity, builds towards complexity, from integers to fractions and real numbers to complex ones. The other, in search of abstractness and logical simplicity, asks what general principles underlie mathematics. Russell's quest led him to the definition of numbers, finitude, correlation and relation, mathematical limits, infinity, propositional descriptions and classes. And at the end of this journey, he arrived at a profound conclusion about the inseparability of logic and mathematics. Russell challenged the notion of logic and mathematics as distinct entities. He saw them as intertwined, each a step in the evolution of the other. To Russell, logic was the youthful exploration, the foundation upon which the mature edifice of mathematics was built. So, as we prepare to venture into Russell's world, get ready to challenge your understanding of logic and mathematics. Are they separate, or are they one the same? As we delve deeper into this question, we may just find that the line between them is not as clear as we might have thought. As we venture into Russell's world, prepare to challenge your understanding of these two fundamental concepts. Now, if we consider a quote by Walter Russell, it reads, "Perfection of rhythm, balanced perfection of rhythm. Everything in nature is expressed by rhythmic waves of light. Every thought and action is a light wave of thought and action. If one interprets the God within one, one's thoughts and actions must be balanced rhythmic waves. Ugliness, fears, failures, and diseases arise from unbalanced thoughts and actions. Therefore, think beauty always if one desire vitality of body and happiness." In essence, this quote speaks to the rhythm and balance in nature, in thought, and in action. It highlights the importance of harmony and equilibrium, principles that are embedded in the fabric of mathematics and logic, each serving as checks and balances for the other. Logic could be seen as the rhythm, the consistent process that helps to establish order, while mathematics embodies the balanced perfection, the precise calculations that bring about results. Together, they form a harmonious symphony, a symbiotic relationship that breathes life into our understanding of the universe. As we continue to explore the world of logic and mathematics, let us strive for rhythm and balance, for harmony in our thoughts and actions, just as Walter Russell suggests. Bertrand Russell once stated, "Logic is the youth of mathematics and mathematics is the manhood of logic." What did he mean by this? Imagine a boy growing into a man. This evolution mirrors the relationship between logic and mathematics as seen by Russell. Logic in its raw form is like a young boy, curious and seeking understanding. It's the starting point, the basis. It's where we begin our journey, asking questions, making deductions, and forming basic principles. As this boy matures, he develops, expands, and deepens his understanding. This is mathematics. It's the grown-up version of logic, where the simple questions of youth have evolved into complex equations and formulas. It's where the basic principles of logic have been stretched, molded, and shaped into intricate mathematical concepts. Now, when we look at this man, we can still see the boy within him. The man wouldn't be who he is without the boy he once was. Similarly, mathematics wouldn't be what it is without logic. The principles, the deductions, the reasoning, all these logical aspects form the backbone of mathematics. Russell saw mathematics as a continuation of logic, not a separate entity. He asserted that there's no definite boundary where logic ends and mathematics begins. Instead, they flow into each other, intertwined and inseparable. Logic provides the foundation, and mathematics builds upon it. One cannot exist without the other, just as a man cannot exist without his past. The relationship between logic and mathematics, according to Russell, is a journey of growth and evolution. Logic is the youth, full of questions and curiosity. Mathematics is the manhood, where those questions are answered, and curiosity is satisfied with knowledge and understanding. So in Russell's view, the line separating logic and mathematics is not only blurred but virtually non-existent. Each is a part of the other. Each is a step in a journey, and each holds a mirror to the other. The boy and the man, the logic and the mathematics, they are one and the same, two sides of the same coin. In modern times, the relationship between logic and mathematics has evolved even further, making the distinction between the two even more impossible. The evolution of logic and mathematics has been a fascinating journey, where both have grown and transformed, influencing each other along the way. In the early days, logic was more about verbal reasoning, while mathematics revolved around numerical calculations. But as time passed, logic took on a more mathematical guise. It became more about symbolic reasoning, using symbols to represent ideas and relationships. This shift brought an element of precision and clarity that verbal reasoning sometimes lacked. On the other hand, mathematics, which was once a field dominated by numbers and equations, started to incorporate more logical elements. The emphasis shifted towards understanding the underlying principles and justifications, rather than just the mechanical techniques. The mathematical landscape started to look more like a logical one, with rigorous proofs and well-founded theories. Take, for instance, the field of mathematical logic, which combines the precision of mathematics with the analytical power of logic. Here, mathematical techniques are used to study and understand logical systems. Theorems are proven not just by manipulating numbers but by using logical reasoning. Similarly, in the realm of symbolic logic, symbols and notations are used to express logical arguments in a clear and concise way. This has been instrumental in simplifying complex logical arguments and making them more accessible. This transformation of logic into a more mathematical form and vice versa has blurred the line between the two to the point of invisibility. Today, it's hard to say where logic ends and mathematics begins. They have become two sides of the same coin, each reflecting and reinforcing the other. As we delve deeper into the complexities of modern logic and mathematics, we see how they have become intertwined. We see how logic has grown up, adopting the precision and rigor of mathematics, while mathematics has matured, embracing the analytical power and clarity of logic. The intimate relationship between logic and mathematics is now evident to every educated student, further validating Russell's view. The evolution of logic and mathematics is a testament to their unbreakable bond, a bond that continues to grow stronger with each passing day. For those who still refuse to accept the identity of logic and mathematics, Russell issued a challenge. This challenge is an invitation to those who are skeptical of the inseparable bond between logic and mathematics to undertake a simple exercise. Russell, in his profound wisdom, proposed a journey starting with premises that are universally accepted as logic and gradually progressing towards conclusions that unmistakably belong to mathematics. His challenge? To identify a precise point where one could draw a clear line separating logic from mathematics. This is no easy task. Russell cleverly constructed this challenge knowing the intricate web that ties logic and mathematics together. It's like trying to determine the exact moment when dawn breaks into day or when a seedling matures into a tree. The progression is so smooth, so natural that any attempt to pinpoint a dividing line seems arbitrary at best. The implications of this challenge are enormous. It forces us to reassess our understanding of these two disciplines. It prompts us to question whether we have been viewing them in isolation, when in reality they are two sides of the same coin. This challenge also holds relevance in our modern understanding of logic and mathematics. Today, logic has become more mathematical and mathematics more logical. The symbiosis between the two is undeniable. The borders have blurred to such an extent that it's impossible to draw a line between them. Russell's challenge is not just about proving the unity of logic and mathematics. It's a testament to the interconnectedness of all knowledge. It's a call to embrace a holistic perspective, to see beyond the artificial boundaries we've constructed, and appreciate the beautiful symphony of ideas that is the essence of intellectual pursuit. So the question remains, can you draw a line where logic ends and mathematics begins? As we wrap up our exploration of logic and mathematics through the lens of Bertrand Russell, we are left with a profound understanding of their unity. What we've discovered is not just a casual relationship, but a deep, intrinsic connection between these two disciplines. We've seen how logic, in its youthful vigor, forms the foundation of mathematics. It's the sprout from which mathematical ideas grow, the starting point of a journey that leads us into the vast realm of numbers, equations, and abstract concepts. It's like the seedling of a mighty oak, containing within itself the potential for grandeur. At the same time, we've learned that mathematics is the manhood of logic. It's where logic matures, blossoms, and reaches its full potential. As we venture deeper into mathematics, we're not leaving logic behind, but rather we're seeing it evolve, transform, and become more sophisticated. Just as an oak is still the same organism as the seedling it once was, so too is mathematics still fundamentally logic. In modern times, this unity has become increasingly apparent. Logic has become more mathematical, and mathematics has become more logical. The line between them has blurred to the point of vanishing. We find logic at the heart of the most complex mathematical proofs, and we see mathematical methods employed in the most profound logical arguments. This perspective, once controversial, is now widely accepted. It has reshaped how we approach both logic and mathematics, leading to new insights, new discoveries, and a deeper understanding of both fields. The unity of logic and mathematics is not just an abstract idea, but a practical tool that guides our exploration of the world. As we delve deeper into the realms of logic and mathematics, we continue to uncover the extraordinary unity of these two fields. Thank you for joining us on this intellectual journey. Don't forget to like, share, and subscribe for more intriguing discussions. Until next time, keep questioning and keep exploring.